In this section, we will illustrate how we can define movie loads. But before going to illustrate this, the definition of movie loads using the CSI bridge, we will first recall the steps that should be done in order to define a movie loads. So a movie loads analysis, it can be used in order to determine the response. When we say the response, that means the internal forces, displacements, rotation, translation, and so on of the bridge structure as a result of the weight effect of vehicular loads, because the function of a bridge is to let moving loads to pass through an obstacle. So this results in the application of the weight of this moving loads on the superstructure. The particularity of this moving loads is that the position of moving loads change along the superstructure, so the effect of this moving loads can also change, and we seek for the maximum and the minimum of the response of a bridge under this moving loads. And in fact, the CSI bridge software let us to get different results and either the maximum or the minimum of different effects. So to define a moving loads, we associate the lanes that we have created with a vehicle that represent the moving loads on the superstructure, and the association of those two, we will first create lanes, then we will create moving vehicles, and we will associate this in a moving load case. No, so a moving load case is an association between lanes and vehicle. Lanes represent the line or area where the live loads can act upon the superstructure. It should be noted that lanes correspond to codes. For example, if we take the Euro code or the AASHTO codes or Canadian codes, the lanes are not necessarily real lanes of where the traffic pass in reality, but they are a model of lanes that is determined by a statistical and a mechanical analysis in order to represent the most severe situation of a bridge. The vehicle can just select it from a set of standard. When we are designing a highway bridge, we use standard. For example, in United States we use AASHTO, in Canada we use the Canadian code, in Europe we use the Euro code. So in each standard highway, vehicles are defined, typical vehicles are defined. So when we are designing the bridge, we should use a code vehicles. It's not real vehicles, but vehicles that are defined in the code we are using. Or we can simply define a user vehicle live loads, and we create it, and then we will apply it. It is the method, the second method that we can use in order to illustrate how to create a vehicle from a blank. So we call this a general vehicle. In highway standard, it depends on what highway standard you used. For example, if we talk about the Euro code standard, we load model 1, load model 2, load model 3, those are the movie loads. In each load model we will find either the axle loads or the distributed loads. So, and vehicle in general are grouped into vehicle classes, what we call the LM1, LM2. That means that we can find for example different military vehicles, that trucks that are used in combination. When we will form the combination in order to design our structure. The military, for example, the military vehicles will, for example, multiplied by 1.35. So first we will create each vehicle, and then we create a class of vehicle that contain all military, for example, vehicles. So in order to define a vehicle, it contains a set of axle loads or a set of uniform loads. Axle loads are a concentrated and point loads. This is the x-axis and this is the axis. Each load is defined by its width, which is a minus z global direction. It is in the minus z global direction, the direction of gravity. So each axle loads will have a mass or a force that will be applied to the structure. And the uniform load is something which is distributed uniformly along such length. Then we can also have a combination of axle and uniform loads. In reality, in general, we cannot find this type of loads, but those are a load model. It's not a real model, a real load, but a load model in order to simulate the most severe condition of moving loads on a structure. So in this case, we can find uniform loads with a length and concentrated force with a total weight. So for set of axle loads, longitudinally, each load is represented by a point or a concentrated force that will be defined by its x coordinate. The weight, we say that it is directed in the minus z global axis. This is in the plane zxz, or the longitudinal axis. But in the transversal axis, that means in the yz plane, each concentrated load can be composed of one concentrated point, or what we call a wheel of a vehicle, or it is the typical vehicle that we have, which is composed into concentrated force. That means this force in the yz plane, it is represented by 2 points. So this total force is divided into 2 points or 2 wheels. This is the most real vehicle, and it can also be represented as a knife edge load. That means that is distributed along a line. For example, if you see this in the plane, that means in the xy plane, then for example, for this case, we will have 2 points here. For example, in this case, we will see something like this. This is the x-axis and this is y-axis. We will see something like this. So those three type of transversely distribution of concentrated loads. The same thing is for the uniform loads. in the longitudinal axis, that means the x-axis, the force is a knife. As a knife, each distribution or a line is distributed along a line. But in the transversely direction, it can be as a concentrated force, or it can be as a knife edge force, or distributed along a length or a long distance. For example, in this case, we will have something like this. In this case, we will have something like this. It is the most common situation that we have when we have uniform loads. We will illustrate how to define different type of moving loads in the CSI bridge.